So all of you can see the screen now.
Yes, sir.
Okay. So from 7:58 to 8:15.
Sir, please arrange it according to the roll number.
Sorry, yes, sir.
Present, present.
Yes, yes, yes. 7:42 to 7:66.
Yes, sir.
Okay. 7:65 to 7:92.
Yes, sir.
Okay. Okay. 7:97 to 8:21. Okay.
Yes, sir.
8:22 to 8:43. Okay. Eight 45 to 8:69. Okay. Yeah. Then up to 8:76. Okay, friends. So I'm closing it. So we are going to the discussion. Okay. Okay. So in the last class, we were up to the organic pollutants, right? Am I right, students?
Yes, sir.
So we discussed about different types of organic pollutants. So today's class would be the treatment techniques. So what are the different treatment techniques, and depending upon the water discharge after treatment, so up to which we should go, and according to our requirement of when we should discharge the water to the environment. Okay. So first we will start with the sewage treatment. So the primary objective is to remove the contaminants from water so that the treated water can meet the acceptable quality standards. Okay. So this acceptable quality standard is up to which what would be the end use of the water. So if it's for agriculture purpose, so then we don't need to go for the advanced treatment, because the advanced treatment is basically for the drinking purpose. So if we want to use that sewage water for the drinking purpose, so then again we should go for advanced treatment. But this is very highly unlikely that any countries are using this sewage water finally to the drinking stage. Very rare. I mean, maybe one or two countries in the world that are using this method. But most of the countries, the sewage water goes to the land, or at the end they end up in river after the treatment. Okay. So the quality standards usually depend on whether the water will be reused or discharged into a receiving stream. Okay, so this is what I was talking about. Advanced wastewater treatment involves physical, chemical, or biological process, or their various combination depending on the impurities to be removed. Because you have different types of impurities. So you have impurities in physical form, some of the impurities in dissolved form, some of the impurities which are harmful for the human and the environment in terms of biological impurities. So So depending on the impurities, so the water treatment goes through different treatment techniques. So if you see the sewage water treatment, the first is the screening step. Okay, the screening is just the physical separation of impurities from the water. So the physical impurities like plastics, the woods, which can be removed simply by going through some filtration process, normal filtration process. There are different ways of removing all this physical impurities from the water. Then after going through that screening stage, then it goes for sedimentation process. So the sedimentation process is done by chemically. So for that we use this alum. So there are different types of alums being used. So the main purpose of this alum is that it segregates all the particulates and deposits from water. So they collect. Yes. Look, students, the attendance thing we can discuss. You will see that, but don't type in the chat box. Okay? Right. So the sedimentation process, particularly, is done by this alum. So and there are different types of alum. These are basically the aluminum salts, potash alum. Okay. Uh, and the main function of this alum is they absorb the particulars that is in the sewage water. Okay, and they collect and they deposit at the bottom of the system or tank, wherever you are doing it. Then after going through that stage, then the water is being treated in a two-way. So one is the activated sludge method, the other one is the trickling filter. So this is basically the decomposition process. And finally, going through this decomposition process, because you have organic matters inside this water. So this organic matters has to be decomposed by different microorganisms. So that can be done by this two method. One is the trickling filter method. The other one is the activated sludge method. So finally, going through these two methods, then the water is going for the advanced treatment. Advanced treatment consists of uh, different techniques. So the techniques are like your reverse osmosis system, you have distillation system, you have also electrolysis system. Okay, so that is the final stage of the treatment, and after that treatment, basically the water is almost drinkable quality. So we will discuss one by one. So first we will see the primary treatments. Okay. So the primary treatment is basically the first two on the screening and the sedimentation process. So the primary treatments also is known as the pre-treatment. You can say that because the secondary and the third treatment is the main treatment of water. That is basically a decomposition process or the removal of very small particles inside the water. But the pre-treatments is basically the physical separation. So it removes the large and coarse solids and inorganic suspended matter. The wastewater is passed through the mesh screen, so that is a physical, so it just goes through some mesh, normal mesh, so having different sizes, so which removes gravels, coarse solids, and slates. Okay. So bigger impurities that is present in your water. For removal of large suspended floating matter, the wastewater is passed through bar screens also. Okay, so de- depending upon like the water is floating in an area, then there is a separation. Okay, and with a bar. Okay, so all this physical materials, so they are just slightly heavier, so they do not cross that bar. So water overflows that bar and this is the way also the physical separation happens without going through a mesh system. Sedimentation, as I told you here, uh, suspended inorganic and organic solids are removed by settling process using continuous flow type sedimentation tanks, and this is often as a chemical treatment. Okay, conditioning is done for the rapid and complete removal of suspended matter. So for this purpose, coagulants like alum, lime, ferrous sulfate, so these type of chemicals are being used. Uh, the materials that float in the settling basin is collectively called grease. So what happens is they stick to these chemicals and they settle down at the bottom of the tank. And these are greasy in nature. Okay, so these are called grease actually. And time to time they remove this grease from the tank. Okay. So the first the pre-treatments is known as your primary treatments. So that includes the screening and the sedimentation process. The secondary is basically known as, or alternatively is known as the biological treatment. So it is an aeration process in presence of microbial population so as to oxidize organic matters present in wastewater. So, the organic pollutants that is present in water is biologically treated, and that is basically done by the all the microorganisms. So it is assessed by the use of biological fill system or activated sludge system. So as I told you, there are two ways to do this process. One is the activated sludge method or the trickling filter method. So we'll discuss one by one. So what happens in this process? In this process, carbon of organic matter is converted to carbon dioxide, and nitrogen is converted to ammonium and ammonia. Okay? So which is finally again converted to nitrates and nitrate. So since organic is consists of carbon, oxygen, nitrogen, okay, so these elements, so the conversion of these organic matters finally results in either CO2, water, or the nitrogen bearing compounds like nitrogen and nitrate. So the first biological treatment is we'll be discussing this trickling filter method. So in this process, the wastewater is brought in contact with mixed microbial population in form of the film of slime attached to the surface of a solid support medium. Trickling filter consists of a rock bed made of furnace slag or crushed rock or anthracite coal or broken bricks uh, with loose packing so as to facilitate the circulation of air. The bed is converted with a biological slime consisting of bacteria. So these are like very big cylindrical well. Actually. So they're covered with this furnace slag or crushed rock or anthracite coal or broken bricks okay, with some gaps, pores, okay, so that the air can pass through that. Because this is important because unless and until the air can pass through that, so this process will not happen because all these microorganisms they need air for the conversion of this organic matters to carbon dioxide and also to nitrogen or nitrates finally. And time to time, water is being sprayed over the bed as it trickles down. The microorganisms utilize the oxygen to decompose the dissolved organic load, and purified water is removed at the bottom. So there's a schematic diagram for this one, how this works actually. So this portion is basically your filled with these broken bricks or the furnace. These are rocks, basically rocks filled with inside that and having some pores. Okay. Then on the top of that you have this biological films, and there is uh, a, a water dropping system here. So water drops time to time. Okay, and the air is coming from the bottom of this system. Okay? So in the presence of water, air, so the microorganisms they convert all these organic matters to carbon dioxide and ammonia and ammonia. So once the dropping water is nothing but the sewage water. Okay, so after the first treatment, so they pass through this media, and during that passing through this media, so they are being converted to or the organic matters from that water would be removed in form of carbon dioxide and the ammonium and ammonia. And finally, the water is collected at the bottom, and some of them will be directly released to the environment, okay, depending on the use, and some of them also go for the final treatment process, okay, that is the advanced treatment or the tertiary treatment. The next one is the activated sludge process. So that is another the biological treatment method. So here aeration is carried out in presence of part of the sludge taken from the previous oxidation process, which is known as the activated sludge. So you can take it from the trickling filter. At the bottom there this activated sludge. So this activated sludge is nothing but having this biological active molecules. So the name is so because it contains numerous microorganisms. So it is known as activated sludge because it is filled with all these microorganisms. Which are ready to convert all these organic matters to carbon dioxide and ammonia. In this process, the wastewater is mixed with proper quantity of activated sludge, and the mixture is then sent to aeration tank, in which the mixture is continuously aerated and agitated to facilitate the oxidation of organic matter. So the process is basically giving some time so that the microorganisms present in that activated sludge treated all these organic pollutants and convert all these organic pollutants to, to carbon dioxide and water and ammonia. Then after treated with this activated sludge, the effluent is sent to sedimentation tank where the sludge is deposited and the clean water is drawn off. For sheeting a fresh batch of sewage, a part of settled sludge is sent back while the rest is deposited off. So whatever sludge, activated sludge is left during that process, again that can be used as a seeding purpose. That means from the first process. Okay, so there's a schematic for this one, activated sludge. So here the raw water enters this tank, okay, and you have this activated sludge, and from the bottom the air is coming. So here after treatment, what happens? So all this organisms, so they will settle down at the bottom. Okay, so that is your activated sludge. You can say that, and the rest of the water, treated water, will fill out. Okay, so once they overflow, so they will go for further treatment or the final treatment. And this waste sludge, you can also recycle it. And also feed to the beginning of this process. They can be act as a activated sludge for the first process or the beginning of the process. The final treatment is known as the tertiary treatment. So this is known as the advanced waste treatment. So the effluent that is coming from the secondary treatment process still contains uh, uh, 20 to 30 milligram per liter of BOD. So BOD is biological oxygen demand. So that means the oxygen required for the biological process. In addition, may also contain significant amount of plant nutrients, dissolved solids, and pathogens. So wastewater from the industries may also contain heavy metals. Okay, so we are not limited to sewage water. Some of the water is also coming from industrial activities. So the water coming from those sources can have also other toxic metals like heavy metals or other contaminants. So for that, we need to go for the advanced treatment process. So depending on the contaminants, so different advanced methods are used in this treatment. So to remove dissolved solids, methods like distillation. So this is the oldest and this very basic method. So what do you understand by distillation, students? It's a very basic chemical process.
Say evaporating and then condensing that
Exactly.
liquid.
Simple. Is it drinkable quality, this distillation water?
Yes, sir.
Okay.
Yes.
It is drinkable quality, but you don't drink distilled water. Why?
So distilled water will absorb the minerals of our body, which will create deficiency in our own body from the minerals.
Exactly. The water we drink is having some different types of nutrients that is required for our body. But distilled water is pure water, no minerals, no nutrients, nothing. So if you drink that mineral water, it is going to dissolve the different salts in your body, and it will create an imbalance. Okay, so different problems will again be created if you drink this distilled water. So never drink any distilled water, although it is the purest form of water, but it's not drinkable quality. The other methods are electrodialysis, reverse osmosis. So and to remove pathogens, disinfection is brought about by the chlorination, ozonization, or UV treatment. If you see the advanced RO system that we have in our home, okay, so at the end we have this UV lamp. Okay, so the job of this UV lamp is to just kill those pathogens. Okay? Because if you expose this pathogens to UV range of radiation, so they just kill those bacteria. So finally, to remove all these biological uh, pollutants, so it goes through the either ozonization process or the UV treatment, sometimes the chlorination. But this chlorination process is again, in some of the treatment techniques they use this at the very beginning of the process. So in the pre-treatment process also they use, uh, and some of the treatment techniques they use at the end. Okay, because if you cannot control the amount of chlorine, again it's going to give you a problem. So excess amount of chlorine is also uh, uh, not good for health. Okay, so and also it gives you a very bad taste to the water. So chlorination at the end or the final stage of treatment is very rare. It's not normally being used at the end, but mostly at the very beginning of the process to kill the pathogens. Okay, so electrodialysis is very basic electrochemical methods. You can say that. So um, to remove different types of ions, okay, dissolved complexes. Uh, this treatment techniques are being used, but it's not that common. Okay, it's not that common. So most the common treatment techniques that we use is the reverse osmosis technique. So what happens in electrodialysis? So it is used to transport ions of salts from one solution to another through semi-permeable membrane under the influence of an electric potential difference, and is uh, achieved in setup called electrodialysis cell. So it's a basic electrochemical setup. So you have two electrodes. Okay. Then you apply the potential across these two electrodes, and there is different semi-permeable membrane between these two electrodes. Okay. Now, when you apply the potential, so the negatively charged ions will go to the positive electrode, and the positively charged ions will go to the negatively charged electrode. So, but during that process, they have to pass through this semi-permeable membrane, which only allows certain ions. Okay, and the rest of the ions will be filtered out. So the electrodialysis unit consists of compartments formed by alternate cationic and anionic exchange membranes. So this membrane, what we are talking about, they exchange the cations and anions with the water. Okay. Cathode is placed adjacent to cation exchange membrane, and anode is placed close to the anode exchange membrane. And water is allowed to enter from the top. So the water is coming from the top. Then you have two electrodes at the sideways. Then in between you have either two exchange membrane, or you can also have series of electrodes and having different semi-permeable membranes with cation and anion exchange property. On application of electric field, what happens perpendicular to the direction of water flow? The ions of salt move towards the oppositely charged. That's what I told you. The membranes alternately allow positively and negatively charged ions to flow through. The result being some compartments will be rich in ions, while others will be free of ions. So below that bottom, so you have different compartments. So the filtered water will be collected in a chamber, and uh, the the water having all these ions, so they will be also collected at another chamber. So they will have different ion concentrations there. Then this, maybe we're missing one slide here. Anyway, so then the the membranes, which type of membranes we are using, like what type of ions it can allow, or what should be the particle size it can allow. So depending on that, different types of membranes are there. Some of them are polymeric, some of them are composite based, some of them are ceramic based. So different types of, some of them nowadays the advanced were based on the advanced materials, like even nowadays the carbon based or carbon based also. So they're coming nowadays. Some of them are also based on nanotechnology based membranes having different pore size. So depending on different sizes of ions, so different types of membranes are being developed, available in markets. So, and mostly uh, these are polymeric based, actually, polymeric based, and also the carbon based membranes. The final process is the reverse osmosis process. So before I discuss the reverse osmosis process, first we want to know what is osmosis. What do you understand by osmosis? Students, it's written here in the slide. Okay, so maybe I can run a video to understand what is the reverse osmosis process. So let me have a look. Unfortunately, I don't have that video here. No, I don't have that video, but anyway, that video is basically nothing but the schematic diagram here we have. Okay, yeah. So this is, so if you see, the left compartment is your pure water, and the right compartment is your salt water. Now, in between these two, so you have a semi-permeable membrane which only allows the salt, which allows only the water molecule to pass through that. Okay. So if you do not apply pressure, the normal situation would be because the salt water is highly concentrated. So the normal process would be, it will flow from this side to that side. Okay. So the mixture of. So after some time, you'll see that they will come to the equilibrium, the equal distribution of ions throughout this water. Okay. But it is not happening because you have this semi-permeable membrane in between that. So it is not allowing any movement of, of, of your salts to the other side of the water. So in the reverse osmosis, what happens if you apply the pressure? So what it will does, so it will allow only the water to pass through that membrane. Okay, only the water, and the rest of the components, which are bigger in size than the water, they will stay in this this channel. So osmosis is just the reverse of this one. So if you do not applying any pressure, so the water will come from this side to the other side. So the mixture of two water will happen. But since you have a semi-permeable membrane, so this is not happening. Okay. But if you apply the pressure on the right hand side, so what will happen? The only the water part from this will pass through that semi-permeable membrane and goes to the other part. So that means only or after some time the highly concentrated water of salts will be in the right hand side, and the other compartment will fill with pure water. Okay, did you get that, students?
Yes, sir.
Okay. Osmosis, it is nothing but if you see this simple osmosis is nothing but it is the difference of chemical potentials. So if you have too high, so one is less concentrated water, the other is highly concentrated water, what will happen? So they will mix. That means the water from the low concentration will mix with the higher concentration because that is a natural phenomenon. So you have chemical potential difference, so they will mix and come to an equilibrium. Okay. Now, in order to avoid that, so first is the semi-permeable membrane is in between there. Okay. So nothing is happening. Okay. We are not allowing any passage of water to the other side. Now, the reverse osmosis is nothing but the applying of pressure. So you're just doing opposite process by applying the pressure in the right hand side. Okay. And the main thing is the permeable semi-permeable membrane. Okay. So which allows only the water to pass through the other chamber. That's it. Okay. So this is what happens also in our advanced RO system. Which is very common nowadays in the West. Now, what is the main component of this reverse osmosis is the semi-permeable membrane. So depending on what type of particles are present in your water bodies. So, so different types of semi-permeable membranes are there. So these are typically in the range of it's not 0.001, it is 0.01 actually, and these are basically the CTA based semi-permeable membranes. So these are cellulose triacetate. Okay, some of them are also composite membrane. And they are also chlorine tolerant. But if you see the advanced semi-permeable membranes, so they are based on this nanotechnology. So TFC membranes are commonly classified as the nanofiltration, so that is, or the reverse osmosis membranes, and these are typically made from polyamide layers, which are like less than 200 nanometer. You also have some polysulfones. Okay. So these type of materials are being used in semi-permeable membrane. So and also the membranes are prepared in different layers. So more layers, the filtration capability is more. So uh, yeah, so the common membranes are like that. But if you see the advanced one, okay, so nowadays also some of the filtration techniques are based on physical pores like nanopores, okay, of having silver or any other materials which have also antibacterial properties. So I think a couple of years back, Tata has also launched this silver-based nanofiltration technique, which are this antibacterial properties. Some of the advertisements you might see that some of the filtration they have this copper membranes. Okay, so these are also having some antibacterial properties naturally. Okay, so also some of the noble metal like golds, platinum, they have also the antibacterial properties. Okay? So that's why we have like in older days, if you remember in literature the description that our ancestors they used to have the utensils from gold or platinum. The only reason is that the if you are having food through those utensils, so some of the nutrients in form of nanoparticles they go to your body system, so which is good in terms of keeping you healthy. Okay. So maybe some of the advertisers you might see that the Zandu, this contrast, they are having also nanoparticles of gold. So it is only the they have this antibacterial properties and also uh, in the longer run, so they keep you healthy. So that was the reason why our ancestors were having utensils from Sone Chandika utensils. Even they're using nowadays. If you go to the market, you can also find utensils from silver. So the reason, okay, because they didn't know the science about the science behind those processes, but the use were coming from the experiences. They use different materials. So they saw over the years that which materials is giving you a healthy life. So based on that, they develop that process. So, but nowadays we can prove that with the science that why the utensils from gold or silver materials. The idea behind it is to give you uh, the nutrients coming from the utensils like gold, platinum utensils. Okay, yeah. So this is the filtration technique for the water. So the next is your the water quality parameters, but most of them you have already done in your labs. Okay, so if you remember the alkalinity experiment, that is the second experiment, if I remember. Then the dissolved oxygen, okay, hardness of water. Then also there is one experiment where you determine the chloride. So all these things are being discussed in the lab. So we are not going through those things in detail. So the next would be the green chemistry. Okay. So that is the preventive methods. So before we create waste in form of air pollution or water pollution, so what are the precautions we can do, or like it's basically the preventive methods. So green chemistry is basically based on the preventive methods or measures that we can follow, so that we can we should not produce any waste from any processes. So be it those processes directly related to are involved in our daily life. For example, whether the transportation or in food industry or the materials industry. So those industries should follow certain rules and regulations, so that at the end the process should not release any toxic gases in form of air pollution or any toxic pollutants, water pollutants to the environment. So there are 12 principles on that. We'll be discussing one by one in next class. Okay.
Yes, sir.
Okay. So today's content would be up to this. Okay. All the three treatment techniques.
Yes, sir.
The quiz time is as usual is 10:30. Okay.
Okay, sir.
Excuse me, sir.
Yes.
Did